Hello! In today's video I wanted to discuss how we can combine atoms together to form chemical bonds between those atoms. So let's go ahead and get started. Oops. So we're going to be talking about chemical bond formation. In order to understand how chemical bonds are formed, we need to understand the structure of the atom. And most importantly, we need to understand the number of electrons that exist in the atom. So we've talked about atomic structure previously, but now we want to really focus on the electrons. So we've talked about electrons, that they exist in these energy levels or orbitals around the nucleus. So electrons are spinning around the nucleus, and when we think about atoms, we organize those electrons into several different levels of energy levels. So we're going to define a couple rules for thinking about how atoms work. And the first rule is that that first level, or electron orbital, contains just 2 electrons. So as an example, on the lower left here is a drawing that we could make of hydrogen. In the middle we've got the nucleus, which would contain hydrogen's proton. And then this circle represents hydrogen's first electron orbital. Hydrogen has 1 proton, so we know that it has, in its neutral form, it has 1 electron. So that electron is represented here in that first orbital. And that's it, right? We're done drawing hydrogen's structure because it has just that 1 electron, and that first orbital will hold up to 2 electrons. Okay. Now for an atom like carbon, carbon's atomic number is 6, so we know it has 6 protons. That means a neutral form of carbon will have 6 electrons. We can take the same process. We've got the nucleus in the middle containing the protons and any neutrons. And then in the first orbital, we're going to place 2 of those electrons. But there are 4 more remaining, so we need to put them in the next energy level out. So we'll draw another circle around carbon and place the next electrons in there. Now the second level has a different rule than the first. So every level after the first can hold up to 8 electrons. And we generally call that the octet rule. So we're going to fill the very first level with just 2 electrons. Every level after that will have 8 electrons. And so we can see that for carbon, there are 4 electrons in that next electron shell. So we can draw that kind of diagram for any atom on the periodic table. And so here are some additional examples, right? We looked at hydrogen and carbon. Get myself out of the way. We can also look at nitrogen. So nitrogen's atomic number is 7. 7 protons in the nucleus. That means there are 7 electrons orbiting that nucleus, 2 in the first shell, 5 in the next shell out. Here we've got oxygen with an atomic number of 8. Again, 8 protons, so there are 8 electrons, 2 in the first shell, 6 in the next shell out. Phosphorus has a much higher atomic number, 15, right? So we're going to need 3 shells to accommodate all those electrons. 2 in the first shell, 8 in the next shell out, and then the remaining 5 in the last shell. Sulfur, sort of the same, a high atomic number of 16. So we have 2 full shells, the first one containing 2, the next one containing 8, and then we're going to have 6 electrons in the next shell out, right? So we can use that information about the amount of electrons to begin to understand how atoms will form chemical bonds with one another. So the first kind of bond we want to address is an ionic bond. Okay, so ions, we've talked about previously, they form when atoms gain an additional electron. That will give that atom a negative charge because electrons have a negative charge. Or if they get rid of an electron, they lose an electron. That means they'll have 1 fewer electrons than they have protons, giving them a positive charge. When 2 atoms form ions of opposite charges, those opposite charges will attract to one another, okay? And that's what we call an ionic bond. So ionic bonds are the attractions between 2 atoms with opposite charges. And the most common example of an ionic bond is sodium chloride. Whoops, get out of the way again. Sodium chloride forms when a sodium atom, which has just one electron in its outermost shell, wants to give away that electron so that it can have a full outermost shell to an atom that requires one additional electron. So chlorine here has just 7 electrons in its outer shell. It will happily take on one additional electron in its outer shell. If those atoms do that, sodium becomes positively charged, chlorine becomes negatively charged, and these opposite charges will attract to one another, causing these two atoms to stick to one another, and that's an ionic bond. The next kind of bond we want to talk about is a covalent bond. Covalent bonds occur when two atoms share pairs or a pair of electrons to fill their outermost shell. So here's an example of two hydrogen atoms. Remember, hydrogen has an atomic number of 1. It has one proton in its nucleus, 1 electron orbiting that nucleus. Again, atoms prefer to have a full outermost shell. So hydrogen would like to have 2 electrons in this electron shell. One way that we can accomplish that is to share these 2 electrons between 2 hydrogen atoms. And when we do that, we'll form a covalent bond. So here's an image of what that looks like. We've got our 2 hydrogen atoms sharing this pair of electrons. Those electrons will orbit equally around both nuclei, and we form this covalent bond. Again, the sharing of electrons between those 2 atoms. It can happen between dissimilar atoms as well. So here's an example between carbon and hydrogen. Again, hydrogen has just the 1 electron in its shell. It would like to have 2. Over here, carbon has these 4 electrons in its outermost shell. Remember, that shell can hold up to 8. So carbon would like to obtain 4 more electrons. And the way carbon could do that is by sharing electrons with hydrogen, 4 different hydrogen atoms. So let's look at what that would look like. Again, we're doing that same sharing between this hydrogen atom and this carbon atom. They're sharing this pair of electrons. That adds an additional electron to the outermost shell of both atoms. And if we set up 4 of those sharing relationships, we make both of these atoms sort of complete in their outermost shell. And so this carbon atom is participating in 4 covalent bonds with 4 different hydrogen atoms. So one thing can happen with covalent bonds is we can get 2 different kinds of covalent bonds. We'll talk about what kind of covalent bonds there can be in a minute. But in order to understand the different kinds of covalent bonds, we should understand one more trait about atoms, and that is their electronegativity. Electronegativity just describes the strength that an atom attracts electrons with. So you can think of this as the strength with which atoms pull on electrons. So I'm showing you here a periodic table of all the elements where in the box we have listed the electronegativity strength for each atom. We can see hydrogen's strength is 2.1, carbon's strength is 2.5, and so on. Some atoms are stronger. Fluorine is the strongest at 4. Some atoms are very weak, like over in the bottom left. Cesium's just 0.7. So these values quantify the atom's strength towards attracting electrons. So how can we use that information? Okay, here's how. So when 2 atoms participate in a bond, we are going to compare the electronegativity values of those 2 atoms. We just want to find out the difference between those 2 electronegativity values. Then we can compare the difference to this information. So first, if the difference in electronegativities is less than 0.5, we say that that bond is a non-polar covalent bond. If the difference in electronegativities is greater than 0.5, but less than 1.7, then we say it's still a covalent bond, but it's a polar covalent bond. And we'll look at what that means in just a second. Okay. If the difference in electronegativities is even greater, if it's greater than 1.7, then we know that those two atoms will form an ionic bond. So by understanding electronegativities, we can understand what kind of bond will form between any pair of atoms. So let's look at some examples here. All right, come back. So what kind of bond? We talked about this bond, a covalent bond between two hydrogen atoms before. All right. So what kind of bond is it? Is it a polar covalent bond, a non-polar covalent bond, or is that an ionic bond, right? And again, we can figure that out by comparing the electronegativity values. So hydrogen has a value of 2.1. Both of these are hydrogen atoms. So 2.1 minus 2.1, the difference is 0. That's certainly less than 0.5. So we know that's a non-polar covalent bond. All right. What about for that example of carbon and hydrogen? This was for a methane molecule. Okay, so we're going to compare hydrogen and carbon because they're participating in the covalent bond. So again, hydrogen is 2.1, carbon is 2.5. Here the difference is 0.4. All right, 0.4 is less than 0.5. So we're going to say that this is also a non-polar covalent bond. All right, let's see if we can find a different example. Here's an example of covalent bonds between hydrogen and oxygen in a water molecule. So what kind of bonds are these? So hydrogen and water. Hydrogen has a value of 2.1. Oxygen has a value of 3.5. So the difference is 1.4. 1.4 falls into this range here for a polar covalent bond. So let's take one more example. We talked about sodium and chloride earlier, so we can compare the electronegativity values again. Sodium and chlorine. Sodium is here at 0.9. Chlorine is 3. The difference is 2.1. That difference is greater than 1.7, which means these two atoms will form an ionic bond. All right. So those are the kinds of bonds we can form. And we'll talk more in another video about polar covalent bonds and just why they're important. But just as an introduction, we said that electronegativity is the strength with which these atoms pull on the electrons. And from this chart, we see that oxygen is much more strong than hydrogen. That means oxygen is pulling on these electrons more, which means that oxygen is going to have the electrons more of the time. Hydrogen is going to be missing out on having those electrons more of the time. Remember, electrons have negative charges. So that negative charge is going to be closer to oxygen and farther from hydrogen. And that means we're going to get some small charge differences in this molecule, where oxygen is negatively charged and hydrogen is positively charged. And we'll talk more about that in another video. So as always, let me know if you have any questions about chemical bonds, and we'll talk to you soon.